CrewtonRamoneStuffsandMath.com.
What are you going to say? You're going to say Happy New Year?
Happy New Year.
Okay. So, 2013. First video of 2013. We're on, what are we on? Take 3 now?
Yes.
Take 4? I don't know where we're at.
Anyway.
Take 3. Alright, so, count this, would you? Please. Look, it's gotten dark to the point where, anyway.
X to the third plus 6x squared.
Right, how many and what time?
X plus 6.
Okay, so x to the third plus 6x squared plus 11x plus 6. There's 3 different drawings of it. So how many in this one? Where's the x? Somebody point to the x to the third.
X to the third plus 6x squared.
Point to the 6x squared. Oh, you're doing a drawing. Let's stay with the first one. Where's the 6x squared in that one?
1, 2, 3, 4, 5, 6.
Right, 3 of them are hiding because they don't look like squares. Right, okay, and then how many x?
Skinny.
Right, they're long skinny ones.
11x.
11x. 3, 6, 9, and 2 more. Yep, okay.
And 6.
And then, when we first did it, they counted that again, because it's a different shape, so they had to make sure, but it's still just x to the third, 6x squared, 11x, and 6, right? You can see it there. And this time we have 4 of the x squareds looking like x squareds, and 2 of them hiding. And then we have 2, 4, 6, and 3 more. Wait a minute, 2, 4, 6, 8, and 3 more to make 11, right? You see where this is good for the little kids to get addends and all that stuff? All right, and then the long one, and the reason why it's fun, this one has 3 different ways to factor it. What do we have? We still have x to the third, but now we have 5x squared, and 1 hiding.
6x squared.
And still, now we have 5x and then 6x. That gives me my 11x. Right?
11x.
And then my 6 is just in a row, right? Okay. Now, the reason why this works is because, look, one side is factorable. So we have x squared, 3x, and 2 on this side. See the x squared, 3x, and 2? And there's x squared, 3x, and 2. You can do it, and you can do x squared, 3x, and 2 in your head because it's the first one, almost the first one we've ever done, right? And we've done it over and over again. It's so easy. And then I can take 2 of the other factors and get x squared, 4x, and 3 when I multiply x plus 3 times x plus 1, right? And there's my x squared, 4x, and 3. And then I could take, maybe make it x plus 1 and then multiply out my x squared, x plus 2, x plus 3, and get one factor being x squared, 5x, and 6. And see, what's x squared, 7x, and 12? What are the factors of that?
X squared, 7x, and 12.
You, be quiet. What's x squared, 7x, and 12? What are the 2 factors?
X plus 12.
And
x plus 3.
There you go. How about if I said x squared, 7x, and 10? Then what would the 2 factors have to be?
X plus 7x and 10? Oh! X plus 5, x plus 2.
Yeah. See, we don't have them anywhere here, and that's the idea, is they get so familiar with the other ones that being able to factor the one side, they can automatically see x squared, 3x, and 2 can be factored. And once we can do that, then we can build it 3 different ways. And all we're doing is counting. And when they're little kids, if these, because you've been fooling around with this a little bit since you were 4, 5, 6, we've played with these a little bit. Well, we weren't doing this when you were 2. We were counting when you were 2.
Well,
but we were
trying to figure out that 1 and 1 is 2.
Yeah, there you go. And that 3 and 5 is how much?
8.
There you go, right? And that what's 7 and 8?
13. I mean 15.
7 plus 8, yes.
It's 15.
Okay. So, yeah, right, getting the addends down. Well, this helps with learning the addends. And they get some third power algebra, and they look brilliant and genius-like when they do it. But basically, all I'm doing is we're figuring out how to factor 6, which with 3 and 2 or 2 and 3 or 1 and 6. And all the different combinations, well, not all the different combinations, but several combinations for 11, where we count 5 and 6, or 2, 4, 6, 8, and 3 more, or 3, 6, 9, and 2 more, etc. Or the combinations for our 6x, where we could have 3 and 3, or 2 and 4, or 1 and 5, etc. Right? That's all it is. We're just playing and counting, staying positive. Later on, we'll get negative. Actually, we've done a little bit of negative work where we, make a factor negative and see what happens and so forth. And then we have to. Then it gets a little more complicated, but it's just more fun puzzles.
Yeah.
But you just baby step your way there, right? You don't have to. It doesn't have to be hard. It can be fun. And the other thing you do, is actually make sure, here, take that.
I got it.
And you right? We're at the drawing stage because these boys have been playing for a while. But you start off playing with these guys, right? And playing on the floor and building on the floor, and then we can draw pictures of them. And now we're at the point where I don't even bother getting out a green pen and a red pen and a blue pen and so forth, because we know the shapes and what they mean, right? But when you start out, you might want to make sure it's color coded so it's really easy for them to count. Bless you. Was that a sneeze? What was that? Okay. So you could count x squared, you know, and make those all red, and the x to the third make that green, and so on. Anyhow, all we're doing is playing around, keeping it easy. Looks really complicated, but once they start fooling around with this, then you'll be able to see.
Yeah.
Yep, there it is.
And you.
Well, okay, so we had this. Okay, so that's x to the third. What are the factors of x to the third? Yeah, do the short side. Okay, the long side. X squared and x. Okay, now I'm saying it's 1,000. I know how much it is. It's 1,000. What are the factors of 1,000?
X squared.
We're in base 10.
100.
100.
And 10.
And 10 hundreds is how much?
1,000.
1,000. And we could count it two different ways. We could count 10 hundreds this way.
Yeah.
Let's put it that way, right?
Yeah.
And we could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. Or we could take out these guys, and it's easier. We could count 1, 2, 3, 4, 5. There'd be 10 of them, right? And that'd still be how many? 1,000, right?
Mhm.
And so what are the? And then let's take this one. What are the factors of that thing?
10.
And
10.
So 10. So 100 is a square number. What's the square root of 100 then?
Oh. This one?
Well, this one isn't a square. This one we made into a long, skinny one. But what if it is a square? What's the square root of 100?
10.
10. Okay, wait. Here, and then we had this one that we haven't even played. We just talked about, but we didn't really play with. And this is, of course, our. Can you open it?
I can. Okay, I can't.
All right. Somebody hold it. Maybe you could stand up and hold it.
Can't see face. I can't see my face.
You can't see. Well, then put it down. There you go. Now you can see your face and hold the 10,000 square. All right. So 10,000. What kind of number is 10,000? Back up. Back up. All right. And there you go. 10,000 is a square. So what's the square root of 10,000?
Square root of 10,000?
What's the square root of 10,000? One side of it.
100 and 100.
Well, 100 times 100, but I'm asking for the square root. So what's the actual proper answer?
100.
100, because that would just be one side.
Yeah.
We can see that 10,000 is a square number. So wait a minute. If that's and we're in base x, what do we call that thing that you've got there? X to the what?
Fourth.
Right, x to the fourth. And what are the sides of x to the fourth?
800.
When we're in base x, what are the sides?
X squared.
Yep. And
X squared.
X squared. Can you put it down the other way so they can see that the other side really is x squared? In fact, actually, sure. Why don't you just hold it like this, and then take this and change it? But we can see that anywhere along there, from there to there, it's x squared, right? And from here to here, it's x squared. Right? Okay. Anyway, and we didn't even play with this one in our drawing. We were just playing with x to the third.
I can draw that.
And we can make more. You could.
But this one would be way too big.
Well, we could still draw it. We just make it smaller. Just make our scale smaller.
Make it tiny.
Like we could pretend that this is x to the fourth, 3x to the third, and 2x squared.
Yeah.
Right?
That'd be so tiny.
Right?
Yeah.
And then you couldn't even see the other stuff, right? We'd have to make our scale slightly bigger. But I mean, you can use your imagination and do whatever you want.
Yeah.
Yeah. Okay.
What else?
So, where do they go for more information?
Crewton Ramone.